Two teams of scientists have spent 30 years measuring one number, not an opinion, not a theory. The single most important number in all of cosmology, how fast the universe is expanding. Both teams are brilliant. Both have checked their work 1,000 times over. Both are certain they're right. And they do not agree. Not by a rounding error, not by a decimal point, by a margin so far outside the bounds of chance that only two explanations are left standing. Either one of the most rigorous fields in modern science has been wrong, in the same way, for 30 straight years. Or the universe itself is not what we've been calculating it to be. Right now, tonight, in observatories on 4 continents, nobody knows which one it is. This is the story of the number that broke cosmology, and the quiet, unproven, deeply unsettling idea that the answer isn't out there in deep space at all. It's exactly where we're standing. Every diagram of the universe you've ever seen is a lie of omission. Stars scattered evenly across black space, like sugar on a countertop. Peaceful, uniform. Zoom out far enough, though, past our galaxy, past the neighboring ones, out to the largest scale anything has ever been mapped, and that picture collapses. The universe isn't scattered, it's structured. Galaxies gather into long, glowing filaments, threads of light stretched across billions of light years, connected at nodes like a net thrown across the dark. And in between those threads, almost nothing. Enormous regions, hundreds of millions of light years wide, where galaxies simply never formed. Cosmologists call them voids. They're not rare. By some estimates, voids make up the majority of the volume of the observable universe. Here's the part that should unsettle you. We're inside one. Astronomers have a name for the void containing our galaxy, the KBC Void, after the 3 researchers who mapped its edges. Some call it, less politely, the local hole. Its estimated diameter, roughly 2 billion light years, not 2 billion miles, 2 billion light years, a distance so large that light itself, moving at the fastest speed physics allows, would need 2 billion years to cross it. Human civilization has existed for roughly 6,000 years. We are a rounding error inside our own address. For a long time, this was treated as trivia, a curious footnote about our cosmic zip code. Then, in 2019, that footnote collided with a crisis nobody saw coming. The number in question is called the Hubble constant. It tells you how fast every point in the universe is rushing away from every other point. There are 2 ways to measure it. Method 1, look backward, all the way back to the cosmic microwave background, the faint afterglow of the universe when it was only 380,000 years old. Feed that ancient light into our best model of the cosmos. Result? Roughly 67 kilometers per second per megaparsec. Method 2. Look nearby. Track pulsing stars called Cepheid variables, whose flicker rate reveals their true distance. Use them to calibrate exploding white dwarf stars visible across billions of light years, and measure the expansion happening right now in our own neighborhood. Result: roughly 73 kilometers per second per megaparsec. 67 versus 73. Both numbers have been independently checked by different teams, different telescopes, different decades of data. The odds this is a random statistical accident. Astronomers put it at less than 1 in a few million. Something is wrong. Nobody has proven what. Here's where the void re-enters the story. Picture a nearly empty bubble, its outer walls thick with galaxies and mass, its interior almost hollow, and our galaxy sitting somewhere inside that hollow. Gravity doesn't work evenly in a situation like that. The dense walls pull. The empty middle has nothing to pull back with, so everything inside the void, including us, should be drifting, slowly, outward toward the denser walls. Scientists call this a bulk flow, and that creates a problem for measurement. When telescopes clock how fast nearby galaxies are receding from us, they're measuring 2 motions layered on top of each other, the true expansion of the universe and our own local drift toward the void's edge. If astronomers have been mistaking part of that drift for pure cosmic expansion, the local measurement, the 73 would come out too high. Not because the universe is expanding faster, because we're moving with it, and mistaking our own motion for the cosmos's. It would not fully resolve the discrepancy. Most researchers think it explains only a portion of it, at best, but it's the closest thing to a suspect this case has had in years. And it comes with an unsettling implication. Our view of reality has never been neutral. It's been filtered, quietly, invisibly, through the specific, accidental patch of the universe we happen to be occupying. If our current address distorts what we measure today, consider what's coming. The universe's expansion isn't just happening, it's accelerating, driven by whatever we're calling dark energy, itself still an unsolved mystery. Distant galaxies aren't moving away from us through space so much as the space between us is stretching faster every year. Run the clock forward far enough, not billions of years, but hundreds of billions. And nearly every galaxy we can currently observe will have crossed a boundary called the cosmological horizon. Beyond it, their light can physically never reach us again. The afterglow of the Big Bang itself will fade into undetectable noise. A civilization arising in that distant future, pointing perfect telescopes at a perfectly empty sky, would see one galaxy, theirs. They'd run flawless calculations and conclude, with total confidence, that their galaxy was the entire universe, that nothing else had ever existed. They would be wrong, and they would have no way of knowing it. That's the quiet, uncomfortable center of this entire story. We assume we're measuring the universe as it actually is, but every measurement is taken from exactly one location, at exactly one moment in cosmic history, and both of those things shape the answer before a single number gets written down. The Hubble tension may turn out to be a flaw in our instruments, or a flaw in our models, or the first real evidence that the cosmos looks different, depending on where inside it you happen to be standing. Nobody currently knows which. What we do know is this. For the first time in a century of modern cosmology, two independent, rigorous methods have looked at the same universe and returned two different answers, and neither one has blinked. Somewhere in that disagreement is a fact about reality we haven't figured out yet. If you want to be there when someone finally does, subscribe, because this isn't a settled story. It's an open case, and the universe still isn't talking.